So thank you very much for that great introduction, Jennifer. Thank you, everyone, for having me here today and for coming. Can you hear me if I wander a little bit and project? I'll stay. I'll just stay close. So I want to thank everybody so much for coming today, and I'll encourage you, if more people are trickling in, please feel free to come down and find a seat anywhere that you're comfortable. And I'll just say one quick point that Jennifer brought up. We were wondering this morning about who might be interested and who might come today. And we were talking about the number of men who tend to arrive at a talk like this. And I said, well, in my experience, going around the country and talking about these issues tends to be somewhere around 5%, maybe 10% of the audience is male. And eyeballing this room today, it is significantly more than that. So I'm really gratified to see that. I'm really gratified to be a part of a conversation at an institution that's really ready to sort of engage on these issues. And I'm really thrilled to be here and thrilled to have the opportunity to talk with all of you about my work on gender stereotyping within academic science. So just to give you a sense for what we'll be covering during our time together today, I'm going to begin with a brief background discussion, presenting some of the evidence for the persistent gender disparity within academic STEM fields. And just when I use this acronym today, I'm going to be referring to science, technology, engineering, and mathematics fields, although much of this evidence is relevant for the medical professions as well. And then I'll briefly talk about the role that gender stereotypes can be playing in contributing to some of these disparities. I'll then talk about some of my work documenting faculty members' gender biases, how those biases could be contributing to the disparity, and the mechanisms underscoring those biases. So not simply stopping at the point of just demonstrating bias, but trying to really go beyond that to understand what are the processes that are driving bias itself. And then moving on to some of my newer work, in the current grants that I've received, I'm focusing on developing theory-based interventions where the goal is to ameliorate these biases. So now that we've determined that bias exists, what can we do going forward to be productive as a community? And then I'll end with a conversation about some remaining questions and some suggestions for ways to move forward. So I'd like to begin by painting a picture of some of the evidence that despite some of the great progress that has been made over the past decades, that there remains a persistent lack of gender diversity at the highest levels of academic science. And to do so, I'll just show you a picture of the last 10 Nobel laureates in physics. So at a quick glance, we can see, perhaps, that these individuals come from the same gender group, that this is a fairly homogeneous group. And just out of curiosity, let's poll the room. Let's take a guess. What percentage do we think of the total Nobel laureates in physics are female? Let's have a guess. What do we think? What percentage? One female, 0%, 2%. Who wants to be wildly optimistic? Anybody? I can't get you to be optimistic at a talk like this. That's fine. So we are at 1%, 2 women out of 193 Nobel laureates total. So we have to go back to Marie Curie around the turn of the last century, and the most recent female Nobel laureate in physics was back in 1963. So not to put all the blame on the physicists, let's turn to a field where the gender disparity is a bit less stark. What's our guess for the percentage in chemistry? Female laureates. 6. We're getting better. 6%? Any other guesses? 10%? Here we are at 2%. So 4 women out of 162. The most recent laureate before the one pictured here is back in 1964. So 1 year more recent. So I bring this up not at all to diminish the incredible scientific accomplishments of these awardees, but again to highlight the fact that despite some recent progress, there remains this disparity at the highest levels of recognition and reward within these academic STEM fields. And when we look more seriously at the data do sort of bear out this trend. So here I'm going to show you, these are women's shares of science and engineering bachelor's degrees by field over the last decade. And what I want to highlight in this graph is that rather than seeing across these different subfields a stark increase in the percentage of women who are getting these degrees, we're seeing that women's participation is often flattening, or in some cases, when we look at computer science, dropping off significantly. So despite the fact that we're having these conversations and trying to think about ways to increase women's representation, there hasn't been this significant increase in that representation. These trends in terms of gender diversity have not sharply reversed. And when we look at this picture at the faculty level, it's a bit more stark. So here I'm going to show you on the y-axis, these are the percent of total faculty that are male and female. Male will be in blue bars, red will be female faculty. And on the x-axis, these are different types of academic institutions. So ranging all the way from R1, or very high research productivity, over to med schools. And we can see at each of these types of institutions a significant gap in the percent of male versus female faculty employed full-time. So we can really see that there remains this persistent lack of gender diversity within these academic STEM fields. And the question really is why? What are some factors that could be contributing to this lack of diversity in these fields? One factor that researchers have considered is intrinsic ability. So perhaps it's the case that women are somehow inherently less capable in these fields. Perhaps there's some biologically linked ability differences that benefit men. A wide body of literature has generated very little supporting evidence to back up this idea. There are some differences between men and women at the very tail ends of the distribution, but evidence suggests that they're very small and unlikely to account for the kinds of stark differences and disparities that I've been showing you in the previous slides. So researchers have turned their attention to the potential role of lifestyle choices. So perhaps it's the case that women prefer careers in other fields, or prefer careers outside of academia entirely, or are choosing to raise children or care for elderly family members, and that the hours spent doing these tasks are simply incompatible with the hours required to spend in the lab for these very competitive science fields. There is some correlational evidence that lifestyle choices are likely playing a role, although it's hard to know how free versus constrained these choices may be. It's hard to know how freely are people coming to these lifestyle choices or preferences, how constrained might they be by experiences of bias or chilly climates. But most importantly, there had yet to be a controlled experiment looking at the potential impact of gender bias on these disparities. So put another way, I wondered, would male and female faculty members who interact with students, who mentor students on a daily basis, would they view an equivalently qualified male and female student equally? Would they evaluate them equally? Would they mentor them equally? Would they advance them equally? Or might there be a biasing role of gender stereotypes, casting men as the more competent scientists in how they would react to these male and female students? And let me say a bit more about what I mean about these stereotypes. So I'm about to distill a large body of social psychological research down into about a slide and a half. So for the social scientists in the room, forgive me, and for everybody, please let me know if I can answer any questions or clarify any of these points. So generally, when we talk about these stereotypes, we highlight the fact that there's a discrepancy between the traits that we tend to ascribe on average to women versus the traits that we ascribe to men and to scientists. And what do I mean by this? So when we think about women, we tend to think about a host of traits that we refer to as communal traits. So we expect women to be nurturing, to be kind, modest, supportive of other people, and generally more so focused on the family and the home rather than the career. And in contrast, when we think of men, we think of these traits that we refer to as agentic traits. So we expect men to be ambitious, dominant, aggressive, analytic, and focused on careers, more so than the home. When we think about these agentic versus communal traits, it's clear that agentic traits map up very nicely with what we would expect of a great scientist. We want a scientist to be analytic, to be willing to take risks in the lab, to be self-promoting, and to be oriented towards a career. But in contrast, when we look at these communal traits, not only do they not fit very well with what we think of as that a scientist needs to be, there's a mismatch here. We don't want a scientist to be emotional, right? We don't want a scientist to be too modest or to be too focused on the home. So these stereotypes result in this end idea that we expect men to be the better scientists relative to women, that science itself becomes male gender typed, that this ends up being sort of a male gender typed task. And many studies support this idea. So for example, a very large, very diverse sample shows an association both on this sort of gut level, an automatic or implicit level, as well as a more stated, self-reported explicit level that people associate science with men more so than women, that we think of science as masculine or more appropriate for men than for women. Another way of getting at this idea is, many of you may have heard of the Draw a Scientist test. So this may be exactly what you're imagining now when you hear the idea. This is a test that has been used with children down to very young age levels and across multiple cultures. And the idea is that you simply ask them, draw a scientist. So draw me what you think of when you imagine a scientist. And repeatedly, this is the kind of thing that they come up with. So when you say, draw a scientist for me, they produce something that looks like this. So on average, I'm not sure what's going on here in this. Something's gone horribly wrong for this gentleman. So they produce something that really taps this idea that the literature supports empirically. So they're producing something that is reminiscent of these fellows, an older white male. So when we imagine who should excel at this work, this is the stereotype that emerges. And interestingly, there are no gender differences in this task. So when we ask little girls, draw a scientist, they produce very similar pictures. Again, something has gone horribly wrong. I can't speak to that. But this really taps this idea. Who do we think is going to be great at this work? The stereotypes support male success, male competence, male excellence, and it's incompatible with the skills we expect and the behavior we expect of women. Okay, so just because these stereotypes exist, does bias stem from them? Just because people have these stereotypes, are they acting on them? Are they being biased towards women in science? As I mentioned, there had yet to be an experiment that tested this directly, but there was related evidence to suggest that it might be the case. So for example, there's a really important report that came out of MIT demonstrating that resources are often inequitably distributed between faculty members, particularly in STEM fields. So for example, women were being given access to poorer or smaller laboratory resources, or being assigned to more committee work that kept them out of the lab or focusing on their research. There are hundreds of studies that demonstrate bias in related fields. So for example, you may have heard of this blinding orchestra study. So there's this really neat study that shows that the way that auditions used to happen for competitive orchestra positions is that people would simply arrive and audition for the piece, for the position. So everyone could see who this person was, all the social groups that they belonged to, whether they were male, female, racial minority. Now, the way that those auditions take place is that they happen behind a screen. So all you can hear as an evaluator is the quality of this person's work. So after the introduction of that screen, the proportion of women who were hired went up by 25%, suggesting that there was some biasing taking place in how people were making those decisions. There was some influence of their gender group that was happening before the screen was instituted. And also interestingly, there are differences in how people write letters of recommendation for very qualified, successful candidates for faculty positions. This study looked at med school candidates. So the letters of recommendation that were written for female candidates were shorter. They included only minimal amounts of information. They expressed doubts about the candidate's qualifications. They said, I think that she would be a great faculty member. I'm not sure, I have some concerns in these areas. And they tended to stress their teaching and mentoring skills, so skills that were less relevant to the research-oriented position. In contrast, the letters for men were longer. They elaborated on the candidate's specific strengths. They did not express doubts, and they focused on the research and publishing skills that were most relevant to the job. So differences in how people are talking about or advocating for, promoting for male versus female candidates. And then finally, female students in STEM themselves are reporting that they perceive they are experiencing bias directed at them from their classmates and from their faculty members. So again, despite these sort of pieces of converging evidence, there had yet to be a clean experimental test for whether bias might be taking place within STEM contexts. So I set out to conduct an experiment that would accomplish this goal, and to do so I recruited about 130 R1 faculty members. These were biologists, chemists, and physicists from around the US. They were 26% female, 19% racial minority, average age of 50, and the key thing to note here is that these numbers are representative of national averages of this underlying population, so we can generalize from these data with some confidence. So the participants read about and rated the profile of a student who they were told had actually applied to be a lab manager within the last year in the US. And they were told that their feedback would be sent to this student. So there were some consequences associated with their behavior. They were told that this was in the service of creating a new mentoring program. And the design of the study was a 2x2, so of target student gender by faculty student gender. And what this means is that everyone in the study saw the exact same materials. They read the exact same description of a student. But for half of the participants, I told them that the student was male, and for half, I told them the student was female. So we can really cleanly isolate the effect of gender. So any differences are just due to the gender of the student. And we also in this study looked at the potential impact of the faculty participants' gender, and I'll say a bit more about that in a minute. And I'll note now that other things associated with the faculty member, the participants, things like their age, their race, the specific science field that they were in, did not have an impact on the results. And I can say more about that if anyone is curious or interested. So here, it's a bit hard to read, but here you can see the lab manager applicant profile that the participants responded to and rated. The key thing to note is that the sole difference between conditions, as I mentioned, was the name of the student, John versus Jennifer, and the gendered pronouns. And I'll note now that we did pre-test these names to ensure that they were equivalent on pretty much every dimension that we could imagine. So they were viewed as equally recognizable, likable, intelligent, warm, competent. So any differences, I could go on and on, any differences between conditions really should be attributable to the gender of the student and not to any superficial differences between the names. So participants then rated how competent they viewed the applicant to be. They rated how likely they would be to hire the applicant for a lab manager position, the salary that they would confer upon them, the salary that they would offer them. And then finally, they completed a scale that measured how likely they would be to mentor them in all sorts of ways that were very relevant to a student who was going to go on to graduate school and a career, a research-oriented career, as this student had indicated in their profile that they wanted to do. So would they mentor this student, advance their career? So the specific hypotheses for this study. The first, we expected that the male student would be rated as superior to the female student for all dependent variables. And again, this would be the first experimental evidence of gender bias within a STEM context. The second, we expected that male and female faculty would behave equivalently. We expected that they would show this bias to the same degree. And let me say a bit more about this. Lots of research has shown that bias is really pervasive, that many people experience it, that is not specific to certain social groups, because it is based on these very widespread cultural stereotypes that we're all fairly equally exposed to, that really well-meaning people display these subtle or unconscious biases. So we did not expect that women would be less likely to be biased than men. We thought that everyone would be sort of likely to be affected by these stereotypes that we've been talking about. This would rule out an alternative hypothesis that I'll call an in-group favoritism hypothesis. So again, we did not expect that people would prefer people from their own in-group, that male faculty would prefer the male student or female faculty would prefer a female student. But we wanted to rule out this alternative in-group favoritism hypothesis and see whether all faculty members would show these preferences. And then finally, we're interested in the processes that would really be contributing to or underscoring, driving these biases. So we predicted that competence would mediate or explain or be driving the hireability gender differences. So really zeroing in on the fact that the bias is driven by these stereotypes of female science and competence, or the stereotypic expectation that men should be the ones who are really excelling in a science domain, as we've been talking about. So let me just show you what this relationship would look like. We expected that there would be an initially significant relationship here between gender and hireability. So being female is associated with an increased likelihood of being hired, but that would drop off to non-significance after accounting for perceived competence. Or put another way, the female student should be less likely to be hired relative to the identical male student because she is viewed as less competent, in keeping with these pervasive stereotypes. So it's this stereotype-linked perception of incompetence that's really driving this hiring discrimination. Any questions about the predictions or the methodology, any of the theory underlying these predictions? Yeah.
So I'm really curious about how you, because there's only one application, so how do you like modulate competence within one person's assessing? Is it going to give two competence scores?
So everybody sees one application, and they're told that it's either from a male or female student, right? And then the competence is their perception of competence. And that's what we want to see. Are they changing their view of how competent this person is just based solely on whether it's male or female? Yeah. Yeah.
But the same person doesn't see.
Exactly. Yep. So.
Not completely.
Right, so we're comparing subjects in one condition to subjects in the other condition, and they're randomly assigned to condition, so no differences between the two participant pools. Okay. All right, so the results. So for this first hypothesis, we expected there to be differences between the male and female student targets on all dependent variables. Here, the scores on the y-axis are these 1 to 7 scales for each dependent variable, which are here on the x-axis. Male students will be in blue and female students in red. And we can see, as predicted, for each dependent variable, a significant difference between the male and female student. And these effect sizes are all medium to large. So again, the female student is viewed as less competent, she's less likely to be hired, and she receives less mentoring than the equivalent male student, the identical male student. No differences in the materials, just the gender is differing. Same pattern for salary. So the male student is offered about a $4,000 per year higher starting salary. This would accumulate into about $16,000 lost pay over the first few years alone. But we know most raises are based on a proportion of your current salary. So this difference would likely widen and accumulate over time. So the second hypothesis, we expected to find no evidence of faculty member gender having an impact here. No differences between the male and female faculty. And that was supported as well. So now I'm going to show you, these are scores for the male student, male target. Here are scores for the female target, the student. Male faculty are in green and female faculty are in gray. And you can see no differences here between the faculty members. All that you're seeing is a significant condition difference that I showed you in the previous slides. So both male and female faculty are preferring the male student over the female student in terms of competence. They rate the male student as more competent than the female student. Both male and female faculty rate the male student as more hireable, more likely to hire that student than the female student. Same pattern for mentoring. So again, both male and female faculty rate the male student. They're more likely to mentor the male student relative to the identical female student. And same pattern for salary. And this may appear to be a slight difference here, actually such that female faculty are offering a lower salary to the female target, but that difference is not significant. So again, no differences here. Male and female faculty behaving just the same, all preferring male student relative to the identical female student. And then the third hypothesis, looking at this competence mediation to see if competence is really driving this hiring difference. So found support for this hypothesis as well. This initially significant relationship between gender and hireability drops off to non-significance when we account for competence. So the reason that this female student is less likely to be hired relative to the identical male student is because she is viewed as less competent, in keeping with these very pervasive cultural stereotypes and messages about female incompetence in science. Okay. So a summary of this first study, this first line of work. Again, this is the first experimental evidence of faculty gender bias within academic science. And I would argue that these results imply that this type of bias could be playing a role in the sorts of disparities that we talked about a few minutes ago, that we looked at in the beginning of the talk. It could be playing a role both indirectly and directly. So directly, if women are encountering very overt instances of bias, they could make a conscious decision that they would like to leave. but also indirectly, perhaps in shaping the kinds of preferences or lifestyle decisions that we've talked about and that other researchers have looked at correlationally. So if they encounter a very chilly climate in a STEM field and perhaps a more welcoming climate elsewhere, then bias could be contributing to those disparities in a more secondary or secondhand way. Also found evidence of this predicted bias mechanism. So really looking at the process underscoring this bias, underscoring these hiring disparities. The difference was driven by the stereotype consistent perception of women's incompetence. So even just going back to that draw a scientist test, when we think of who we expect to be great in this domain, those stereotypic perceptions of competence resulted in this significant hiring discrimination against a female scientist compared to an equivalent male scientist. And finally, I think it's really critical to stress that this bias was not exhibited by a subgroup of participants or certain faculty members. It was pervasive throughout all of the faculty members that we looked at in this study. It really gets at sort of how subtle this process is and may be exhibited even by highly well-intentioned people who value the contributions of female scientists. This driven by exposure to these very pervasive cultural stereotypes. So rather than it being an in-group favoritism effect, male and female faculty, young and old, biologists, chemists, physicists, everyone is showing these effects because they're all fairly equally exposed to these stereotypes. And then finally, for all these reasons, and I'll talk about this a bit more in a few minutes, there are clear implications for student evaluation procedures and for academic mentoring policies. The goal of lifestyle choices aside, I think we can all agree that an equivalently qualified male and female student should be evaluated equivalently, should be mentored equivalently, should be advanced equivalently. And unfortunately, we now have evidence that on behalf of the faculty members who work with these students on a daily basis, that's unfortunately not the case. Okay, so let's not leave it there. What can we do? So I'm going to talk about a couple of suggestions that are ranked in terms of their resource investment, and then I'll transition into talking about some newer research on interventions. So what can we do now knowing that these biases are affecting our academic science community? So what are some things that we can think about going forward? So first, participating in some honest and straightforward conversations about the existence and the prevalence of bias, how it could be affecting our decisions. So one very straightforward way of defining bias is just simply an error in judgment. And that is a way of thinking about it that doesn't necessarily imply a negative intention on the part of the person who's enacting the bias. And I think that's a good way to think about it. I don't want to underestimate either the difficulty or the importance of participating in these kinds of conversations, particularly because we now know that bias is so pervasive across people from different social groups. One really powerful study, I think, shows that, ironically, bias is often strongest amongst people who most believe that they are egalitarian, who most value their egalitarianism. And that's because they're least on guard against these sort of creeping effects of bias. So one really important step is to say, we're all equally exposed to these stereotypes. We're all likely to exhibit biases. What can we now do as a scientific community to move forward and contend with these subtle errors in judgment? So next, I think that there are some simple changes that departments can make today or tomorrow, if you want to be a little more realistic, to some hiring and mentoring policies that could push back against some of these subtle bias processes. So thinking about mentoring, there are ways to make the mentoring process a bit more transparent. So for example, setting up advising schedules that are transparent and that guarantee equal access to a mentor's time from students from all different backgrounds. So that pushes back against these creeping effects of bias so that any student, regardless of whether they might fit the prototype that a mentor might have subtly of who's most likely to succeed, but any student has equal access to their mentor's time and mentoring abilities. Or the assignment of secondary mentors. So we know from another really great line of research that one of the biggest predictors for success in academia, particularly for women and racial minorities, is identifying with a role model. So if we assign a secondary mentor, we can increase the likelihood that that identification process will take place. Second, when we think about the hiring process, yeah?
How do you think that first
We should assign secondary sponsors. Yeah, no, that's a great point. So I think that we also need to couple this with structured and evidence-based training on mentoring for faculty members, which is maybe a little more resource intensive.
Sponsorship is for people who don't know.
So there's a difference between just sort of saying, I will mentor you on paper, and not actually being a true advocate in a day-to-day sense, versus sponsoring, which is conceived as really being in someone's corner and helping them in instrumental ways that advance their career in a more day-to-day, long-term sense. And I think evidence-based training on mentorship, which there are several programs now that have exciting evidence that they're effective, could be one way to implement more of a sponsorship role amongst many faculty and mentee pairs, or sponsoree pairs, we'll say that. So when we turn our attention to thinking about the hiring process and how hiring committees work, there are a couple of changes that have been made in many institutions that are supported by a lot of evidence. And the first is to establish very clear evaluation criteria before a search begins. So to say, what are we looking for and how will we know when we've found it? So who's this great candidate for us and how are we going to figure out when we found that person before the search begins? And second, to have members of the committee rate the candidates independently on an objective or concrete measure before they come to the meeting. So making things as concrete as possible can guard against some of these creeping effects of bias as well. Yeah?
But you said that female candidates were less likely to receive the kind of recommendations and evaluations that would, in fact, register on those criteria. So
Right.
How would you account for that?
So we can't fix everything with, by tweaking this just by any one of these means. But if we think about the search committee angle, then we can ensure at least that qualified female candidates who are reaching that level will be reviewed equivalently. Then we have to think about how we're writing those letters as well. But if we think about the search committee angle, then we can do something about the evaluation piece. It's a great question. So a next recommendation is that we think about the idea of implementing funding-linked training on subtle bias, the same way that we receive training in responsible conduct of research for people who get grant funding from NSF and NIH currently. So we could wrap this training into these existing RCR, Responsible Conduct and Research programs. We currently take the ethical and responsible treatment of our research participants very seriously, as evidenced by these RCR classes. There's no reason why we can't take the ethical and responsible treatment of the people conducting the research just as seriously. And then finally, to advocate additional research on the testing, the design, and the implementation of interventions that are designed to reduce these kinds of subtle biases. So I'll spend the rest of our time together today talking about some of my work in this area, but additional work, now that we know that this bias is an issue, additional work really testing these interventions I think is really critical. So currently underway, I'm working on a large-scale randomized control trial that's looking at interventions targeting bias amongst STEM faculty members. But today I'll share with you some preliminary data on evaluating another intervention. So the research question here really boils down to, can diversity courses reduce gender bias and promote diversity within STEM? Can these serve as effective interventions? So within this research, we tested the efficacy of one such intervention, which is called scientific diversity. So wanted to see whether this functions as an effective intervention within this context. And scientific diversity is a diversity course which was specifically designed for academic scientists with the needs of this population and community in mind. And specifically, we present them with the social science literature on gender bias, the benefits of diverse learning communities, and other related topics. And we utilize what's called an active learning pedagogy or teaching style, which involves this very active, experiential, participatory classroom And we present the attendees with the social science data on these topics and encourage them then, once exposed to the data, to draw their own conclusions. So to use their own sort of scientific reasoning abilities to take from these data the logical conclusions. And then finally, we end the session with practicing concrete strategies that they can implement back at their home institution. So leaving with some actual tools in their toolkit rather than just sort of talking about these issues and raising anxiety without knowing what behaviors to implement. So the design for the study, participants again were about 130 academic scientists. This time they were majority female, self-identified as white, same average age, nice spread of where they were in their own careers. Nice spread of different types of institutions, although still majority research one, and in this case, majority public institutions. In the design of this study, the scientific diversity interventions were run at 7 different National Academies Summer Institutes on Undergraduate Science Education, so these are professional development opportunities for scientists, and one of the courses that they were able to take was this diversity course. And they were implemented over the course of the last summer. And they took a pre-test and a post-test. The pre-test was 2 weeks before the intervention took place, post-test 2 weeks after. So there's this month period in between this longitudinal design where we're assessing change over this 4-week period. And all measures are administered online in this random order. So we're interested in this study in 3 key outcomes. The first outcome is participants' awareness of diversity issues. A lot of work has shown that an increase in knowledge about diversity itself is a key precursor to subsequent behavioral change. So we're wondering, does this intervention simply increase their awareness of diversity issues, that this is an important topic? So the first hypothesis, we expected that their knowledge of diversity issues at time 2 would increase relative to time 1. We used an item that has been used in previous research: to what extent do you think that your own institution is diverse? So getting at their awareness of the homogeneity of their own institutions, the lack of diversity surrounding them. And the second outcome that we were interested in was their subtle gender bias itself. And we reasoned, in keeping with previous research, that for this population, a subtler, more contemporary form of bias would be more likely to be relevant rather than a more traditional, overt, hostile form of bias. So we assessed this with a previously used scale, the modern sexism scale, again expecting that we would find lower levels of bias at time 2 relative to time 1. Items in the scale include things like discrimination against women is no longer a problem in the United States. So endorsing a measure like that would indicate that a participant was expressing these sort of modern or more contemporary, subtler forms of gender bias. And good reliability at time 1 and time 2. So finally, we were interested in this variable that I'll refer to as self-regulation. So again, there's a vast literature within social psychology on self-regulation. And I'll sum this into sort of the key points to take away. So when I refer to self-regulation, I really mean our ability to maintain motivation and focus throughout a task. So how we keep ourselves going throughout a tough task or performance. And there are 2 basic ways in which people go about self-regulating or approach this task. So one is a promotion focus. You can think of this as an approach orientation. So going after something great, approaching your goals, trying to get a job or get a publication in a great journal, be hired for something or get positive attention from a teacher or professor. And in contrast, we have a prevention focus. So you can think of this as avoidance orientation, trying to evade negative outcomes, not be fired, avoid negative attention from a boss or a coworker or a professor. So an approach orientation, a promotion focus, going after something great, versus a prevention focus, avoidance, staying away from something negative. And as you may expect, the literature indicates that increased promotion focus is really the key outcome here. This is what we see as being associated with great performance across a variety of domains. So we really want to see that people are able to go after their goals, particularly in this intergroup or diversity domain. So increased promotion focus is associated with things like increased support for equality and preserved resources during difficult intergroup interactions. So what we really wanted to see is, would participants' promotion focus when it comes to managing diversity in their professional lives, would that increase? And would their prevention focus then remain stable or decrease? But the promotion focus increasing was the really key outcome. So the predictions here, we expected at time 2 that we would see an optimized self-regulatory state relative to time 1. So an increased promotion focus and a stable or a decreased prevention focus. So people really going after their goals and not becoming too avoidant or worried about failure when it comes to diversity. And we assessed this with a previously validated scale. The promotion items were things like, right at this minute, in terms of my approach to diversity, I'm feeling free to pursue my goals or focused on what I will achieve. And the prevention items, I feel as though I need to avoid risks or like I don't want to make any mistakes. And again, good reliability at both time points. So here I'm going to show you the results of linear mixed effects modeling. And what this means is that these are the results controlling for all the variance at the level of those 7 different institutions that I told you about. So there's all sorts of variability that could be associated with attending one of those 7. They took place at different times, different people taught the classes, there were different folks in the classes, one of them might have had just a really annoying person. So these statistical analyses control for all of that variance, and you're just seeing the effects of those 3 DVs over time, above and beyond all of that individual variability. So here we can see that, as predicted, their awareness of diversity increased over that month period after participating in the intervention. And their subtle gender bias decreases. So they're becoming less biased over this month period during which they participate in the intervention. To give you some evidence of what we would refer to as discriminant validity, I'm going to show you that we also measured subtle racial bias. So the intervention did not talk about race at all. We didn't touch on racial bias or racism in the academy. And then we measured this scale and didn't find effects. So it's not that participants are just responding in the ways that might be socially desirable or what they might think we would want to hear for all scales. They're only showing movement on the items and the topics that we actually talked about and targeted in the intervention. It's not just showing an improvement over a month on anything. They're only showing improvement on the things that actually should have been affected by this very specific intervention. And then finally, for the last hypothesis, we find support for this optimized self-regulatory state. So we see that their promotion focus is going up. They're focused on achieving their diversity-related goals, and their prevention focus remains stable. So they're not becoming more risk avoidant or fearful or avoiding failure more so. So they're going after their goals and related to a diversity context. Do you have a question?
Yeah, I was curious, how exactly did you measure the subtle gender bias? Because it seems like, the previous PNAS paper test didn't really work.
Yeah. So it was an established scale that had been used before. Okay. It was a validated scale.
And these are just like questions they
Yep.
answer, or?
Mm-hmm. And that scale was actually used in the PNAS paper too. We can talk more about that if you have more questions towards the end. So let me just wrap up, and then we'll take some more questions. So summary for this line of work. Implications for this intervention study, this first in a series of intervention studies that are currently underway. Preliminary evidence that diversity courses like scientific diversity can function as effective interventions in this domain. So preliminary evidence. Specifically in this case, there was evidence that it increased participants' awareness of diversity issues, reduced their subtle gender bias, modern sexism, and optimized their self-regulatory state. So going after their goals and not becoming more defensive or avoidant. That's something that we worry about a lot in these situations sometimes, that they're going to hear about all of this stuff, learn about all of these diversity-related things, and then become paralyzed. Or even there will be some backlash. And we did not find evidence that they were becoming more risk avoidant in this case. So next steps. Currently underway is a large-scale randomized controlled trial funded by the Sloan Foundation that compares scientific diversity to a host of other creative interventions to see which is most effective with this population. So of course, important goals: assess generalizability, replicate with a randomly selected representative population, including a control condition to really zero in on the effectiveness of the intervention itself. And I'm really excited and interested to move beyond self-report measures. So I think it's critical to look at subtler bias, implicit bias, using reaction time measures, which I can talk more about for folks who are interested, and really importantly, looking at third-party ratings of behavior itself, really assessing participants' behavior rather than their self-reported assessments of their own change. And really the broader goals of this intervention work is to bring a very rigorous, robust scientific approach to the ways that we design and test and implement interventions that are hopefully helpful in terms of thinking about reducing bias. So let me just leave you now with a couple of final thoughts. So we've talked about some data on documenting bias and reducing bias. But ultimately, why should we care? Why should we care about diversity within STEM and bias within STEM? Why is this important for us within this community and beyond this community? Why is this a critical topic? So a couple of reasons. First, there's a pressing shortage of STEM workers. So a report that came out of the White House a few years ago indicates that we will have a 1 million person shortage of trained STEM workers over the next decade. We will be short 1 million people in this country to do the jobs that we need done. One way that we can begin to close this gap is if we do a better job recruiting and retaining populations that we historically have not been great about recruiting and retaining. And doing a better job reducing bias and connecting with talented female scientists would be one way to begin to do this. The problem is not going away on its own. This is not something that will simply alleviate or fix itself if we do nothing. There's no age effect. There's no cohort effect in any of our studies. It's not that the younger participants are not showing this bias, whereas the older folks are the ones showing the bias. So this is something that we need to engage in more actively if we're going to see these biases reduce. STEM jobs are great jobs. We can talk about the excitement of science, and I think that that's really important, but even more so from a more data-driven perspective, unemployment rates are lower in STEM relative to other professions and fields, and particularly for women working in STEM, they're earning about $6,000 a year more per year. They're earning about $6,000 more per year than women employed in non-STEM fields. So these are wonderful opportunities, and we should be clearing the pathways for interested and talented individuals. And finally, we know from colleagues in organizational behavior and industrial organizational psychology that diverse groups often do better work, produce great and exciting outcomes, particularly when different perspectives are valued and encouraged. So if we can recruit a more heterogeneous population, there could be really exciting scientific discoveries and advances that result. So for these reasons, in this case, gender parity is really in the best interest of our national competitiveness and the advancement of the scientific enterprise. We need our researchers and our labs to be functioning at the absolute highest levels. And if these subtle biases are systematically preventing the full participation of people from certain backgrounds, then we all stand to suffer. We all are affected. So in this case, the goal of this work is really to understand how it may be that gender stereotypes are affecting bias processes and maybe reducing women's full participation with the broader goal of enhancing meritocracy and diversity and excellence within academic science. So I want to thank my fantastic team of collaborators on this research, really wonderful, exciting interdisciplinary team, funding sources for this work, and all of you for being here today. And I'm really eager to hear your comments and questions. Thank you. So I see a hand here first. I'm going to try to restate questions for the video feed.
Okay. My name's Jennifer. You can call me John. So my question was, if women are biased or have stereotypes toward other women, do they also hold these same stereotypes toward themselves? And what role does that play?
Great question. So John wants to know. if women have these stereotypes towards other women, do they also have these stereotypes towards themselves? So I think you're getting at internalization of these stereotypes. The short answer is, unfortunately, yes, absolutely. So there's all sorts of neat work thinking about women's sense of belonging in science and how they view themselves and their own goals as potentially at odds with the goals that they see as prevalent throughout science domain. So Amanda Diekman's work is really great at piecing apart sort of how these things are undermining women's excitement about science and their intention to persist in science careers. So women view themselves as having what she refers to as communal goals, so goals to help other individuals and to work closely with other individuals, sort of in line with these pervasive stereotypes about how women should behave. And they view science, unfortunately, I think this is a real tragedy, as more of a lone wolf type endeavor, that you can't help people if you are a scientist, and you can't work with others closely if you're a scientist. So when she does manipulations that describe science as more collaborative and more useful and helpful to others, then women's sense of belonging and intention to persist in science increases. But generally, yes, they are self-stereotyping. Yeah.
I thought your newest findings were encouraging, but to be a little bit pessimistic about them. I'm guessing that we don't yet know how long the effect persists.
Right.
And also, can you say a little in the absolute sense? I mean, the numbers changed a very small amount, and should we be thinking about that too?
Yep.
I mean, is there a culture that in the world that shows zero gender bias?
Okay.
We shouldn't, I think, lose sight of the fact that that's really what
Yep.
we should be trying to get to.
Yep. So a few questions there. You're thinking about longitudinal effects of interventions, how big the effects are, and is there a non-gender biased culture? And if so, I think we should all move there. This is my opinion. So longitudinal question is a great one, and that is a big part of the current RCT. We have longitudinal measures up to 6 months out. So that's something that we're really excited about seeing, is how long are these effects lasting. The work that I know of currently that looks at interventions aimed at reducing implicit bias has only gone so far out as 2 weeks. So we know that we can effectively reduce them out to 2 weeks, but life is long. It's longer than 2 weeks, so we want something more long-lasting. And it's a great point. The effect sizes in this study are medium. So social scientists get really excited about slopes that look like this, but those translate into meaningful differences in the real world. But you're absolutely right that we're not finding whopping differences right now. This is a conservative preliminary test. So we need this RCT to see what happens when we're able to really compare between conditions. So really promising pilot data that I just saw right before coming here today for that RCT, that it's looking like there are some really exciting differences between conditions. So stay tuned. And your cross-cultural question, there's no gender, there's no society that I know of that doesn't display gender biases at all. There's a scarcity of cross-cultural work on these issues, period. There's several studies that have come out recently looking at countries and cultures that have implemented more gender progressive policies in the workplace. So countries like Sweden have come out with a lot of data recently. And the newest study that I reviewed recently showed some promising data that men's and women's endorsement of traditional gender roles is reduced in those countries, but bias itself doesn't seem to have been lessened quite yet. So it may be a cohort effect. We may need to sort of wait for the policies to catch up with people's actual categorization processes and the way that they react to these things. So I think that we need more research and more time. Yeah?
So how extendable is this to other disciplines, whether it's in business or education or even the arts?
So question about extending these results to other disciplines. And I'll say that I think this study was one to see whether results from those other disciplines would replicate in science. So there's lots of previous work within corporate settings. I don't know of any in the arts, but within corporations that shows these effects quite strongly. When my collaborators and I were thinking about conducting this study, we would hear from our colleagues quite a bit, oh, you'll never find bias within the sciences, because scientists are objective. And so I think this study, we joke frequently, the study kind of showed that scientists are people, and that we're subject to the same kinds of processes that are driven by stereotypes as other humans. And really what, the theory behind this work is that bias is driven by exposure to cultural stereotypes, which are quite pervasive. So I don't know of any work in the arts, but I would say that artists are also people. And I think that the theory underscoring this should generalize to many different kinds of professional contexts. So I saw a hand here. Yeah, go ahead. Yep.
Thank you very much.
Thank you.
If you had a certain amount of money to spend on personal interventions, such as the study you described in detail, versus structural approaches, which you described earlier, such as applying definite criteria, having individuals on search committees, evaluate individually the contestants, which do you think has the most potential long-term benefit if that is defined as increasing diversity, if that's the endpoint?
Yeah. We need more research on structural interventions. I firmly believe that there's two ways to think about it. One is individual strategies that we can use as, anecdotally in individual careers to sort of survive. And then there's more widespread strategies that can be implemented structurally to fundamentally sort of change some of these basic processes. And we just haven't been able to I think, in a more systematic way about evaluating some of those potential changes, and that's happening a lot more recently. So I want to cheat and say both, but there's been a lot of conversation about individual strategies, particularly since Lean In was published, and I think that it's great to have suggestions to make to individual men and women who can't necessarily wait for this widespread cultural change. We can't wait for stereotypes about men and women to be fundamentally different before we all have careers that we're busy wanting to lead. So I think it's great to have those individual strategies, but you can only lean in so far. And I think having those structural changes as well is absolutely critical.
I think the question might have also been about the training individuals, like
Yeah.
the scientific diversity course, versus putting in place processes.
Mhm.
So,
Yeah.
again, if you had limited dollars, is there evidence to say that one is better than the other?
So I'm a social psychologist, and we think a lot about the individual level. So I know of more research that looks at sort of those individual judgment levels. So from an empirical perspective, I think the evidence really speaks to those individual pieces. I would get really excited about those structural changes as well. So I'm going to cheat again and say both. I think we need both. Yeah.
So there are data suggesting that children think about going into STEM fields even during the early elementary years.
Mm-hmm.
So is there any evidence that there is bias that occurs because you're talking about a million person shortage, and those numbers are enormous and make a difference here in medical school, but it sounds like there needs to be major changes made at the K-12 level.
Yeah. So the question is differences at the K-12 level to sort of address this shortage. Absolutely. So there's really compelling research with children, down into the elementary school ages that show that those children are showing, automatic implicit associations, just like the ones we talked about, down to extraordinarily young ages. We don't see a big gap in terms of achievement or interest necessarily quite that young, but they are aware of the fact that science is for boys, math is for boys, even down to these extremely young ages. So I think you're absolutely right. Interventions that say, yes, you are great at this, and this is for everybody, is an exciting way to think about progressing. And I don't know of anyone who's working on that systematically. There's ads, I don't know if everyone saw, there was like the Goldilocks toy company came out recently that just shows young girls being excited about engineering. But I don't know personally of anyone working from a scientific perspective about exciting younger girls about science yet. But I think it's a really important way to go.
I want to make sure the students and the postdocs have a chance to ask Dr. Rakusin some questions. So why don't we just take like one more in the general group, and then I invite all the students and postdocs here to join us in S362. You go through Pete's to the room behind. One more.
So I guess I'm a student, so I could go to that thing. But I had a general question about, a lot of this is the focus on the word diversity, and diversity offices and blah blah, and efforts to increase diversity. And to me, the word it seems to have a more of a morally compelling to me. But I also understand that maybe you want to emphasize the positive aspects of things rather than the negative aspects. And so I was wondering if you could speak to that a little bit.
Yeah. So there's some neat studies. I've done some work looking at framing for these courses and how it affects people's excitement to participate in them. The short answer is that when you talk about it in a negative sense, people view it as a punishment. So when you say inequality or discrimination or bias, even bias, for a course, people then view it as it's something that they have to attend, it's punitive, and they're going to be blamed for something. And there's a lot of research to show that when you blame people in these courses, there's this boomerang effect, and that paradoxically they become more biased as a result. So that's sort of the framing for we find more buy-in when we frame it around this positive goal that everyone can work towards and share in. When I hear what you're saying, that there is this sort of moral piece that diversity may not be capturing, but I think the things we stand to gain by framing it as the shared goal rather than a negative outweigh that.
Okay, please join me in thanking our special guest.